Hello, children. Today we are talking about scientific notation. Scientific notation is a way that we can use, that we can write really big numbers or really small numbers. It's kind of like a shorthand. It's like a shortcut to writing really big numbers or really small numbers. So, some things. And this involves using exponents. So we're using exponents to write our scientific notation. So here's a table of some things that we know. If I have 10 to the power of 1, that equals 10. That equals 10. Okay? If I have 10 to the power of 2, that equals 10 times 10. That equals 100. If I have 10 to the power of 3, that equals 10 times 10 times 10. That equals 1,000. If I have 10 to the power of 4, that equals 10 times 10 times 10 times 10, which equals 10,000. Now, what I want you to see is, and let's also add up to the very top. I have 10 to the power of 0. Anything to the power of 0 equals 1 equals 1. Okay, so this chart here is going to be a lot of how we get to our scientific notation. So, let's say I have something like, we'll go with 512 times 10 to the power of 3. Okay, well, 10 to the power of 3 is 1,000. So really this is 512 times 1,000. And now timesing something by 1,000 means I'm going to add my 3 zeros to the end. And I'm going to get 512,000. Okay, so that's kind of like scientific notation. That's not quite scientific notation. There's some things that need to happen in order for this to be scientific notation. But this is a good start. So when we're timesing something by 10 to the power of something, we're going to be keeping our number the same, right? Our number is the same in all of these, 512, 512, 512. But we increased our place values. We moved our decimal point away and made a much bigger number. We started with 512. And we moved our decimal point in order to get us 512,000. That's scientific notation. Scientific notation is all about increasing or decreasing our place values while keeping the rest of our numbers all the same. Okay, so if I were to go back, let's start this again. Let's say I have the number 1.79 times 10 to the power of 7. This right here is scientific notation. The way I know this is scientific notation is my number here. My number is a value. This is less than 10 greater than 1. So my value is a number where I have a number in my ones place followed by a decimal. So I only want a number in my ones place. I don't want a number greater than my ones place. I don't want to have 32.78. This would not be scientific notation because this number is more than 10. I don't want it to be more than 10. I want it to only be a number in my ones place value. Okay, so I know starting off this is scientific notation because my number here is less than 10 and greater than 1. And then I also know it's scientific notation because I am multiplying by a power of 10. So another way to know what scientific notation is multiply by power of 10. So all of this, all in all together, is scientific notation. All right, that is my scientific notation. Number that's less than 10, greater than 1, and I'm multiplying by a power of 10. So to take this number here, get rid of all this extra nonsense now. To take this number and to turn it into scientific notation, what I want to do is I want to move my decimal the number of times, that's not a word, the number of times my exponent tells me to. Okay, so the number of times my exponent here is this 7. My exponent is going to tell me to move it 7 times, so I'm going to take my number, 1.79, and I'm going to move it 7 times. 1, 2, 3, 4, 5, 6, 7. And I fill in my blanks with zeros. So this would be a 0 here, 0 here, 0 here, 0 here, 0 here. If I were to write this, I would end up with 17,900,000. So 1.79 times 10 to the power of 7 is the same thing as 17,900,000. Now, if you notice here, this 1.79 hasn't changed. I still have my 179, 179. Those stay the same. The thing that changed was moving my number the number of places my exponent tells me to. Whoa, that was cool. Uh-oh, too far. So I move my decimal the number of places it tells me to. All right, now let's try it again. Let's see another one that we see. Let's say I have 3.248 times 10 to the power of 5. Is this scientific notation? Yes, it is. My first number is less than 10, more than 1, and I'm multiplying by a power of 10, 10 to the power of 5. So I'm going to start by writing my number, and I'm going to move my decimal 5 places. 1, 2, 3, 4, 5. Fill in with a couple zeros, and I get 324,800. This would be my number. This is the number in scientific notation. This is the number in standard form. Scientific notation and standard form. All right. Let's say I want to go from standard form to scientific notation. Let's say I have a really big number here. Let's say I have 958 million. Let's say this is my number here, 958 million. And I want to put this into scientific notation. Well, I want to do what I've just done, but do it backwards. I want to take my decimal, that doesn't exist, but I know it's at the very end of my number. And I want to bring it all the way back until it's in between my first two digits here. So I'm going to bring it back 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to write all the numbers that I need to. I don't need to write my zeros, but I'm going to write 9.58 times 10 to the power of 8 because I moved my decimal 8 places. Since I moved my decimal 8 places, that's going to be what goes in my power here. Okay? So the number of times I move my decimal is my power. The number of times, or my power tells me how many times I move my decimal. All that decimal moving comes from my power here. And then my digits all stay the same. This 958 is going to stay the same. And I always move my decimal in between my first two numbers because I need it to be less than 10, more than 1. All right. For you to be successful in math, go ahead and write this as scientific notation. Have a great day.